Good afternoon, class. Today we're going to do some more solving for variables and equations. We're going to do some multi-step. So I'm going to define here, or redefine. This is something we've worked with before already. So we are going to define what it means to be a like term. So in this case, when we're dealing with like terms, first of all, identify that a term is just a number and a variable, or the product of a number and variables. So each term here is separated by either a plus or an equal sign. So we have three terms up here. Like terms are those that have the same variable and exponent. So we are always looking to combine these, and that's what we're going to do today, is combine these. So the first thing we're going to do is an example. So let's do example 1 here. And our idea here is to combine these like terms. We can see that 11m and 6m are alike. Now, an error that a lot of students make is they don't realize that this 6m is negative 6n or minus 6n. So we're going to rewrite this as plus and negative, and then we're going to use the commutative property to move things around a little here. So we're going to take 11m minus 8 plus a negative 6m. So I'm just rewriting the minus 6m as plus a negative 6m so that I can take this here, like terms, and combine them. So 11m plus a negative 6m. And we're going to keep that minus 8 in there, and we're going to work with that in just a moment. So 11m plus a negative 6m is 5m. Now we can just go through our steps that we did before, and that was to add 8 so we can undo the minus. Again, since we're doing this plus 8, that will drop the minus 8 out of the problem. So we get 5m equals 30. Divide by 5. The reason why we're doing that is so we can drop the 5 from this side, and we get m equals 6. Just as always, you should check your answer. So put 6 up here for m. Just check to make sure that that works. Now we're going to do a word problem. And in the word problem, it's important for you to realize that we need to identify the variable and where that is in the problem. So what I'd like you to do is go to the question. How much is one pack of strings? So the variable will always be identified after they've told you a whole problem. They will identify the variable down here in the question. So how much is one pack of strings? So a pack of strings is what we're looking for in our problem. So anywhere we see that, we're going to tie a variable to that. So we're going to read through the problem. Noah and Kate are shopping for new guitar strings in a music store. Noah puts 2 pack of strings. So here we have pack of strings. Kate buys 2 pack of strings. So again, we see that place where we're going to identify a variable, and a music book. The music book costs $16. Their total cost is $72. So we can see we're going to have 2 variables here, the same variable. So we need to identify a variable for that. So we're going to define C to be pack of strings. So we're going to rewrite the problem, but we're going to use an equation to do that. So the amount that Noah spent on the strings, so he had 2 C's, plus the 2 that Kate bought, plus the music book, which we know was $16. That total cost has to be the $72 that they spent. So we can combine these two to get 4C plus 16 equals 72. Now we're just solving for the variable C. So 72 minus 16 is going to be 56. We divide by 4, and we get C equals 14. So then our answer being 14 is telling us that there are $14 per pack of strings. So that would be the answer to your question. So $14 for the pack of strings. That's per. So that's how you answer the question for that one. Now we're going to do some other problems where we're going to throw in some extra steps. So when we're dealing with parentheses in the problem, we're going to treat those just like we would any problem. We have to distribute. So we're going to take this 3 and distribute it to the 2x and the minus 6. So we're going to get 6x minus 18. So we had to distribute, so 3 times 2x is 6x, and 3 times 6 is 18. Keep the minus in the problem. So we've just, in a sense, just simplified the problem so that we can answer the problem and find the variable. So now we're just going to solve for x by adding 18. We're adding 18 to get rid of that minus 18. So we're going to get 18 plus 18 is 36. We then are going to divide by 6 to drop that, and we end up with x equals 6. Just like always, take your x equals 6 and check. So put it right in here for x and check your work. We're also going to be dealing with fractions today. I'm going to do this problem 2 different ways. The first way, I'm just going to solve it and keep the fractions as they are. And then the second way, I'm going to show you how you can actually eliminate the fraction if you choose. So here we have 2 variables that are the same, 2b and 3b. Well, we're adding them, so you have to remember, in order to add fractions, we have to get like denominators. So I'm going to change my denominators to be 20. So in order to do that, we would need to multiply 2b over 5 by 4 over 4. So that's going to make this 8b. So I'm multiplying this fraction by 4 over 4, just to get it common denominators. This one we're going to have to multiply by 5 over 5, so that's going to make this 15b equals 3. So we just got like denominators. This is nothing new. I'm hoping that you'll understand that step. Now we can actually add the fractions together. So we're going to take 8b plus 15b and get 23b over 20 equals 3. So now that we've combined the like fractions, or the like terms, we can now go ahead and solve. So there's 2 different ways you can solve for this. As we've talked about before, we can do it in 2 steps. We can multiply by 20. So we get 23b. So that drops this 20. Since we're dividing, we're multiplying. So we're going to get 23b equals 60. So then we can divide by 23 and get b equals, so we're going to get a decimal here, 2.6, but I don't want decimals, so we're just going to leave this as a fraction. So we're going to leave it as 60 over 23. Rather than have a decimal answer, we're going to leave it as a fraction. So you can take that 60 over 23 and simplify that into a mixed number if you want, or keep it as an improper fraction. Either way is acceptable. Okay, now we're going to do a decimal problem. And, before I do that, let me show you the second way to do this problem. I apologize. I was going to show you a second way to do this problem. So let me go back to the original. 2b over 5. So we have 2b over 5 plus, let me get the rest of the problem here, 2b over 5 and 3b over 4 equals 3. So the second way to do this is to identify the common denominator, and don't actually change the denominator, but multiply everything by that denominator. So the common denominator is 20. So what we're going to do is we're going to multiply the entire problem here, everything in this, by 20. So 20 times 2b over 5. So that's going to reduce. So we're going to get just 8b. 20 times 2 would be 40b over 5 would reduce to 8b. Okay. Now we're going to take 20 and multiply by 3b over 4. Well, that's just going to reduce to 15b. So again, we'd do 20 times 3, you'd get 60b. 60b over 4 simplifies to 15b. And then we have to multiply 20 times 3. So 20 times 3 is going to give you 60. So now we have gotten rid of the fraction. So we're multiplying everything by the common denominator to reduce the fraction, or get rid of the fraction. Now we could just add these two together, and we're going to get the same answer. 8b plus 15b is 23. So we get the same answer. It's just we're multiplying everything by the common denominator to clear the problem of all the fractions. So it's entirely up to you as to which way you want to do it. You can keep the fractions, or you can multiply them out and try to get rid of them. Now we can go on to the decimal problem. And in the decimal problem, there's no like terms to combine, so we're just going to simply go through and try to solve for x. So we're going to be dealing with decimals. So most of you will be able to do this on your calculator. We're going to add 2.325 to both sides. That will drop this out of the problem. So we're going to take 3.95 and add 2.325 and get 6.275. 0.5x. Divide by 0.5 to get our final answer. So we're going to end up with a decimal here. And as long as the problem started as a decimal, we are okay to keep it as a decimal. If the problem did not start with a decimal, then we would need to leave it in fraction form. So that's all for today. So after the video, you can answer the questions associated with this video, and then bring your notes to class with any questions.